Okay, so P4 supplying electricity. So a battery or a cell provides a direct current. So we have to know first the differences between the current and the potential difference. Current is amount of a charge passing through a wire in a certain time. Potential difference V is the amount of voltage in battery. So we have two different types of current. We have direct current, the current that only flows in one direction. And this direct current produced by direct potential difference. Another type of current is alternating current, AC. The direct current is DC and alternating current is AC. The current repeatedly reverses direction and is produced by alternating potential difference. So we have two different types of current, direct current and alternating current. I'm going to show you pictures about the differences between direct and alternating current. So this one, I'm looking for this one. So for the direct current, the volt is direct. The amount of volt per unit time is going to be direct, and the current per unit time is going to be direct. The direction of current of the voltage is always constant. But for alternating current, the direction of current always switched, as you see, perpendicular in a periodic manner, and the voltage is also switched. So we have two different types of direction of current. If the current moving in one direction and the voltage is constant, is going to be direct current. If the current moving in opposite direction and switching periodically, so the current is going to be alternating, and the voltage is also going to be alternating voltage. So we're going to go back. Yes, plugs. So we have many different wires in plugs. So the first one, official, the plug, we have many different wires. The first one, this one is called the earth wire. The earth wire, this the green one, this no green. Okay, this one is called the neutral wire, and this one is the fuse. So the earth wire is a safety wire to stop any devices becoming live, appliances becoming white. The potential difference of the earth wire is 0 volt. It only carries a current if there is a fault. So this is the earth wire. The neutral wire complete the circuit, as you see here, complete the circuit, and it has a potential difference also of 0. This is the plastic is used for the wire coating and the plug case because it's a good electrical insulator to protect you from any electrical current or any type of electrical leaking. So this is the plastic wire. This is the fuse. Fuse is very important. Fuse connected to the live wire. If the live wire fuse connected to the live wire, if the live wire inside appliances touches the neutral wire, a very large current flow. This is called short circuit. When this happens, the fuse melt and disconnect the live wire from the mains, keeping the appliances to be in a good or to be safe. The live wire is dangerous because it has a high potential difference. It's around 230 voltage, This would cause a large current to flow through you if you touch it. So be careful if you open this and this is connected to the, if you open the plug and plug is connected to the electricity, be careful because the live wire has electricity, a huge electricity coming from the 230 voltage. The last part of the plugs is most electrical appliances in UK are connected to the mains using 3 core cap. Copper is used for the wires because it's a good electrical conductor and it bends very easily. So this is the structure of the plugs: earth wire, neutral wire, plastic, fuse, and live wire. Okay, national grid. The national grid is a national network of cables and transformers that link power station to homes, offices, and other consumers of mains electricity. Transformers are devices that can change the potential difference of alternating current. So if you see this is a power station generating an alternating potential difference of around 25,000 volt. This one is a step up. We have two different types of transformers. We have step up transformers and step down transformers. Step up transformers, this one, are used to increase the potential difference from the power station to the transmission cable. The transmission cable over here is a national grid transfer electrical power at potential difference to 400,000 Kelvin. Oh, that's why we are using here step up transformers. We have two different types of transformers. The first one is called step down. Step down transformer take a high volt and transfer it to a low volt. Step up transformer, it changes the low volt to the high volt. That's why the 25,000 increases to 400,000 because of the step up transformer. Okay, what happened next? We have a step down transformer. We cannot transfer 400,000 voltage to our houses. So it's going to be very dangerous. So we have to use another transformers, but this time it's going to be step down transformers. Step down transformers are used to decrease the potential difference from the transmission cables to the main supply in homes and offices so that it's safe to use. Homes and offices use electrical power of around 230 voltage. In Egypt, we are using 220 voltage. In USA, we have 120 voltage. So the difference, it depends on the, and we have 220 in different places here in UK and USA. In UK, the potential difference in homes and offices is 230. So the national grid is very easy. Power station generating electricity by around 25,000 voltage. Then step up transformer increase the temperature, the potential difference to 400,000 voltage. And then step down transformers decrease the temperature, I don't know why I'm saying temperature. Increase the potential difference again to be suitable for the homes and offices, and it decreases from 400,000 to 230. Okay, so far we learned the alternating current, alternating potential difference, charge flow, fuse, national grid, and the short circuit. Short circuit, this one. If the live wire incident and appliances touch the neutral wire, a very large current flows, and this is called short circuit. Okay. What is next? Why do transformers improve efficiency? So this is pure mathematical part. So I would like to explain this in a different OneNote file. Oh, when we record this, the OneNote file is not appear with the recording. So let me open from here. Okay. Let me open from here. First of all, you have to know the Ohm's law, V equal IR. You are familiar with this formula before? Let me ask Jana. Do you know Ohm's law?
No, sir, it's the first time to hear about it.
Okay, Bisan.
This is the first time I hear about it.
Okay. So let me stop here and explain to you. Anyway, I'm gonna explain here in OneNote file. You see my OneNote file? No one answer. Guys, you see my OneNote file? Roa, you see my OneNote file? You see this page, the white page?
Yeah,
No,
I
sir.
can see.
Okay. Sometimes I'm sharing it and doesn't appear in your screen. Okay, so I'm gonna define first the current. Current I is amount of a charge moving through a wire in a certain time. I equal Q over T. Q is the amount of a charge and T is the time. So wire current is measured by unit called ampere, A. And for small wire, we can use milliampere or microampere and so on. V, potential difference, the potential difference V is measured by volt, and we have a relationship between potential difference and current. So potential difference exactly is like the energy used between 2 points in the circuit. The potential difference, you can find the potential difference in battery. So if you have circuit like this is the battery. Here is the potential difference. And here is something here. I'm gonna explain this to you. And for example, here is the lamp. And if you need to put switch here to open and close the switch. So this is a whole electric circuit. So the current is moving this way, for example, I. Here is the potential difference. This one is called resistance. This is the resistor. And the resistor may use to regulate the amount of current moving through the circuit. So resistance is measured by ohm and taking the symbol I. Ohm is like this, omega. Ohm is taking the symbol omega. Okay, so I have three different quantities, V, I, R. We have a relationship between them. Ohms, one of the physicist scientists, he did experiment. He changed the amount of V and record the amount of I for a certain circuit. And he found V directly proportional with I. So the relationship between the potential difference and the current are linearly proportional. Means if the voltage increase, the current increase. He did the famous law in electricity called Ohm's law, potential difference between the circuits equal the current flowing in the circuits multiplied by constant, which is R. This is measured by, potential difference is measured by volt, I is measured by ampere, R is measured by ohms. Okay? So why I'm explaining this? Because we have power of electricity. Power equal I multiplied by V. If I take off V from here and I replace it by IR, so P equal I multiplied by I, R is going to be I square multiplied by R, right? So if you understand this and we go back here, P equal IV and B equal I square R. So I explain it from scratch because I know most of you don't know what is Ohm's law. I explain it from scratch. So if you look to here and you go back, this one, where is the OneNote file? Over here. So it's the same. Who can give me the power in terms of V? Power equal V and R. V multiplied by R, V divided by R, V multiplied by R square, V divided by R square. Can you give me the relationship between power and V and R? Who can answer this? Who can give me the relationship between V and I and R? Hello? Unmute yourself and answer, please. Hello. I have one answer in the chat. V equal IR. Mahmoud, I need the relationship between power and V. Power and V. Guys, just rearrange the equation. Just rearrange the equation. Take off I and put V over R. No one answer. I have answer in the chat here. Can you repeat the question? I need the relationship between P, V, R. Can you put them in one relationship together, please? Okay. Okay, no problem. Okay, guys, we talk from Ohm's law, V equal IR, right? If I need I, is gonna be V over R, right? You have problem with this? Okay, so V equal IR over V? No. Mahmoud, IR is V. So B equal 1? You give me IR P equal IR over V? No. So I said definition of B equal IV, right? I took off V and I bought IR, so the definition of P, another formula is I square R. You agree with this? So if I ask you to give me the relationship between B, I, and R, you're gonna put this one. P equal I square of R. I am asking about the relationship between P, V, and R. So what you're gonna do? You're gonna change I and put V over R. So it's gonna be V over R multiplied by V is gonna be V square over R. So we have three different equations for power. Power either equal IV, the general formula, or I square R, or V square over R. And the unit of power for all of them is what? Is what, which is WATT. Okay, I saw your answer. So I think now the relationship between IV and power and R are very clear. So we're gonna go back to here. What do transformers improve efficiency? A high potential difference across the transmission cables means that the lower current is needed, to transfer the same amount of power. Power equal current multiplied by potential difference. A lower current in the cable means less electrical power because the relationship between current and power is directly proportional, and that is wasted due to heating of the cable, since the power lost in heating cable is power W equal I square multiplied by R. This makes the national grid an efficient way to transfer energy. If 100% efficiency is assumed, so the potential difference, primary potential difference, V primary, multiplied by primary current equals secondary potential difference multiplied by secondary current. Do you know why this equation? Because the primary power equal the secondary power. Power equal IV. Okay. Electric transfer in electrical appliances. So before going to this, can you look to this screen for 10 seconds, 20 seconds? I need you to keep in your mind the relationship between B and V and B and R, because we're gonna use in the next slide. Okay. So energy transfers in an electrical appliances. Electrical appliances transfer energy. For example, a hair dryer transfer electrical energy electrically from the chemical store, the foil in a power station, to the kinetic energy store of the fan inside the hair dryer, and to the thermal energy store of the heating filaments inside the hair dryer. When you touch an electrical appliance on, the potential difference of the main supply causes charge carrying by electron to flow through it. So I just give you the current equal Q over T over here. Current equal, what is that? Current equal Q over T. This is the definition of current. So if you need the charge, if you need Q, you can multiply I by T. Q equal IT. So Q equal IT, the charge flows through any appliances, equal current multiplied by times. You can find the energy transferred to an electrical appliance when charge flows through it. So if you need the energy transfers in Joule, not the power, don't confuse between the power and the energy. Energy equal QV. So the power, we took the power equal IV, power equal IV, but the energy and power measured in watt, and the energy transferred equal, measured in joule, equal charge multiplied by potential difference. So now we need to have a relationship between the power and energy. Power and energy. So let me explain it to you here. We said energy equal QV and power equal IV, right? So how we connect them together? Imagine I divide that energy by time. So I have to divide this by time, right? What is Q over T? If I divide energy by time, what is the value or electrical quantity represented by Q over T? Who want to answer, guys? You can write in chat. What is Q over T? I just mentioned it. I have answer in the chat. Ro'a and Ahmed, mashallah. So Q over T is I, right? Is the current. Oh, so if I divide E over T, the equation here is gonna be IV. What is IV? Power, right? So power equal energy per unit time. Very simple. I'm trying to explain the connection or the relationship between power and energy by a very simple way. Just you have E equal QV. If you divide E by T from the left-hand side, of the equation, you have to divide on the right-hand side. So you're gonna have Q over T here. So power equal Q over T is I. So the same like the power. So power equal energy per unit time. Power equal energy per unit time. Okay. So I need to give you the unit of charge flow is C. Who know what C means? You know A is the ampere. I just give it to you. Time is second. Energy transfer is measured by joule. Potential difference, I said, measured by voltage or V. Power is measured by watt. Can you give me the name of this quantity of this unit C? What is C referred to? Anyone knows? C is what? C is the unit of charge, not current. C is not the current. C is unit. Current is physical quantity. I need answers, guys, in the chat. Guys, give me the answers, please. Ampere, no. Ampere is the unit of current, which is A. I'm asking about C. I am asking about C. Charge is Q. Charge is Q.
Is it Coulomb?
Yes, who said that? Roa?
Yeah.
Thank you, Roa. Guys, don't confuse between the physical quantity and the unit. Current is a physical quantity. The unit of current is ampere. Time is physical quantity. The unit of time is second. Charge flow is physical quantity. The unit of a charge flow is coulomb, which is C. So if I ask you what is the coulombs mean, coulombs is the unit of charge flow through a wire. Direct current, you know, direct potential difference, you know, step up transformer, step down transformer. I think you know all of these definitions. So here are the questions after each class or each lesson. How does a material become charged, become negatively charged by gaining electrons and positively charged by losing electrons? What will two objects carrying the same type of charge do if they are brought close to each other? Same charge. What happens for the same charge? Repeal. Repeal. What happens to the strength of electric field as you get further from the charged particle? The strength of electric field. Yusuf, Joe, this is no AB physics. This is IG physics, Habib. What is the electric current? The rate of flow of a charge. What unit are charge, current, time measured in? Charge measured in coulombs, current measured in ampere, time measured in seconds. What is the same at all points when the charge flow in a closed loop? Current will be the same if we have a closed loop. What must there be in closed circuit so that the electric charge can flow? You should have potential difference between the sources or source of potential difference. Which two factors does current depend on and what are their units? Current depends on ohm and voltage according to Ohm's law. What happened to the current if the resistance increase, the current should be decreases right away. What is the ohmic conductor? Conductor where current is directly proportional to the voltage, so the resistance is constant. What happens to the resistance if the temperature increases? Resistance increase with temperature. What happens to the resistance of the thermistor as the temperature increases? So the resistance decreases with the increases the temperature of thermistor. What happens to the resistance of a light-dependent resistor when the light intensity increase? Light increase means the current increase, so the resistance should be decreases. What are the main features of series? Oh, I'm going to explain to you what is the series circuit and parallel circuit. I have to explain first before doing this. So Jana, can you tell me what does this mean? This part of electric circuit, but what is this part? Jana?
Yes, sir. Can you hear me?
What you said?
Which part?
The one
Which
I draw it here.
No, sir, I told you from the beginning that I can't see the white screen. I just can see like a questions and a pink thing.
Guys, can you see the screen, white screen? Bisan, can you see the white screen?
No, I see the questions.
Yeah, same.
I asked you from the beginning many times.
I told you, sir, no, I can't see it, but he didn't hear me.
And what about now?
Yeah, now I can.
That's why I'm asking you many times, guys. This group, I find very hard time to communicate. You are not unmute yourself and talk with me. So did you see this? Did you see all of that?
No.
Oh my God. Okay, why you are not unmute yourself and talk? Okay, I'm gonna explain again. Okay. I was here for 5 minutes, so all the time on the PDF file. So you good except in this part. I explained the current I equal Q over T. This is the definition of current. I equal Q over T. So the current I equal the amount of a charge passing through the wire in certain amount of time. The current is measured by ampere, which is taking the symbol A. We have milliampere and microampere for small current. V, the potential difference, is the energy used between 2 points in the circuit. This is the electric circuit. We have battery, which is the source of potential difference. We have this symbol, this is called resistor. And the resistor has a physical quantity called resistance. Resistance measured by R, and take the unit ohm and the current passing through the circuit. So according to Ohm's law, Ohm did a simple experiment. He changed the potential difference in a certain circuit and record the time each time. The current each time. He found as the potential difference increases, the time increases, or the current increases. So he postulate the mathematical formula. He said V equal I multiplied by constant, which is resistance. So as the resistance increases, the current decreases. As the potential difference increases, the current increases. You know, if you have two different quantities on the same side of the equation, so if one increases, the second one decreases. But if you have two different quantities in opposite side of the equation, one increases with the increasing the second one. Then I explained the power. I said the power equal IV. If I take off V and I put IR, so the power equal I multiplied by I is going to be I squared multiplied by R. And then I asked, can you give me the relationship between power and V when you take off I and put V over R? You didn't answer me. Now I understand you didn't see the screen. So if I need the relationship between power and V and I and R, I'm gonna take off I this time and put V over R. So it's gonna V over R multiplied by V is gonna V squared over R. So I have three different types of equation of power, either IV, the general one, or I square R, or V squared over R. All are measured by what? Then I explained E equal QV. And I said, if I divide E by T, I have to divide the other side by T. So QT is the same like I. So if I divide E by T, is going to be IV, which is the power. So the power equal E over T. I explain it all again. You got it? So what is the symbol? What this symbol means? No one answered again.
Resistance.
Yes, exactly. This symbol measure resistance. This symbol is resistor and is measuring the resistance. Okay. What happens if I connect another resistance like this and another one like this? So this is R1, this is R2, this is R3. Do you know what this connection means? I'm gonna give you choices. This is gonna be series connection or parallel connection.
Series. Perfect.
This is series connection. What about if I connect the resistance like this?
Parallel.
This is gonna be parallel connection, right?
Yes.
Okay. You know what happened to the current here? If the current is 5 ohm, here is 5 ohm too, here is 5 ohm, here is 5 ohm. Oh, so the current in series connection is constant. Do you know what happened to potential difference? If potential difference is 20, once moving through the series connection, potential differences start to be divided. So you have V1 here, you have V2 here, you have V3. So potential difference is divided or not constant variable. In the parallel connection, the opposite side. If you have 20 potential difference volt, so V here is going to be 20, 20, 20. So potential difference here, which is V, is going to be constant. And the current is going to be divided. In your opinion, which one used for the connection, for connecting the current in our homes? The series or the parallel?
Parallel.
If you need to connect your phone, your computer, the air dryer, whatever, many devices. You're gonna connect them with the same current, all of them with the same current, or with different amount of currents. So it's gonna be better connection.
Yes.
Okay, we're gonna go back to the last two definition now. What is the main features of series connection? Same current through each component. So if you understand this, same current, this statement is gonna be very clear. Same current through each component. Total potential difference of power supply is shared between components. Total potential difference is shared between components, as I mentioned here. The total resistance here, R total, is going to be R1 plus R2 plus R3. Let us continue. You are seeing the switch between the white node and the PDF, right?
Yeah.
Alhamdulillah. Total resistance of all component is the sum of the resistance of each component. So without showing you the drawing and explaining in the one node file, I think this statement is very difficult to understand. What are the main features of parallel connection? Potential difference, each branch is the same. The current through the circuit is the sum of current in each branch. Total resistance is less than the resistance of the smallest individual resistor. So one can ask me how we can calculate the total resistance here for the series. You know how to find the total resistance? 1 over R total equal 1 over R1 plus 1 over R2 plus 1 over R3. You're going to take this in details in one of the circuits classes. So the total resistance in parallel connection is going to be less than the smallest resistance in the circuit. The total resistance in series connection is going to be, for sure, you're going to add all of them, so it's going to be larger than the largest one. Okay. So we done. We need to answer one of the questions. Can we work in this example, please? Let me choose one example related to. Okay, let us do this because we have only 10 minutes. What is 021? Yes, start from here. Student has a small electric motor. They connect the motor in a circuit with 6-volt battery and current of 1.5. Show the power of motor. Show that the power of motor is 10 watt, 9 watt. How? How the power equal 9 watt? Okay, this is very simple. Power equal IV, and you said I is 1.5, and you said V is 6. When I multiply 1.5 by 6 is going to be 9 watt. This is how to show that the power equal 9 watt. Very simple. Okay, let me move down. I have to erase the drawing to move down. The student turns the motor for 30 seconds. Write the equation that links power, energy, and time. Who can give me this equation? Power, energy, and time. Power, energy, and time. No one answer. Okay.
Power equals energy over T.
Exactly. Thank you. Who's this? Roa?
Yeah.
Thank you. Power equal Bisan. Power over time equal energy. No, power equal energy over time, Bisan. Not power over time equal energy. This is the equation. Calculate the energy transferred by motor. So P equal ET, E over T. So if I need E, I'm gonna multiple power by T. I just rearranged the equation. The power is 9 watt. What is the time? What is the time? 30. So you're gonna multiple 30 by this is 270, right? 270 joule. Okay, guys. Let me go down for 2.4. The student finds the lamp with the same power rating as the motor. They connect the lamp to another 6-volt. Then they turn the both circuits for 30 seconds. Select the correct statement below. Which one you select?
For the same rating.
The student find a lamp with the same power rating as the motor. They connect the lamp to another 60-volt battery. Then they turn both circuits for 30 seconds. Select the correct statement below. Okay, can you think about this and take it as a homework? And I am gonna give you another one as a homework over here. Can you take a screenshot of this page? Can you do 3.3 and 3.4 as a homework? Okay, guys, today we explain the power, the direct energy, indirect energy, and the plugs, the structure of plugs, and the transfer of volt from the power stations to our homes, and what the national grid, the transformer, the step-up transformers, step-down transformers, and we took the relationship between potential difference, current, power, energy, amount of a charge, and we solved some of the equation. And we also explained the series and parallel connection. You have any questions? Okay, guys. See you next week, inshallah. Assalamu alaikum.